Good morning, respected scholars and other participants who are here to participate in this cloud based international conference organized by Sbyte Technologies. Now, I would like to introduce myself. I'm Sahana Sridhar, currently doing my BE final year in the stream of Computer Science and Engineering at St. Joseph's Institute of Technology. My today's topic is the literature study on some computational healthcare systems for sustainability. To give a brief introduction about this topic, today we are facing a situation wherein we are flooded with tons and tons of information and data from every aspect of our life, such as social activities, science, work, health, and etc. The technological advances have helped us in generating more and more amount of data, even to a level where it has become unmanageable with currently available technologies. This has led to the creation of the term big data to describe the data that is large and unmanageable. In order to meet our present and future needs, we need to develop new strategies to organize this data and derive meaningful information. One such special social need is healthcare. Like every other industry, healthcare organizations are producing data at a very tremendous rate that presents many advantages and challenges at the same time. The diversity of the data content requires a unified programming interface for multiple data analysis modules. The analytic techniques have also become extended to require the complex analysis for accommodating the four characteristics of big data in the medical field due to the inconsistencies in the sources, structures, functional scenarios, and nature of the health. The days of collecting data on electronic health records and other structured formats. Diversified medical data includes structured, semi-structured, and other unstructured data represent one aspect making medical data both interesting and challenging. Based on different data structures, the system can efficiently deploy and analyze data online or offline, such as via stream processing, batch processing, iterative processing, and interactive query. Therein, this reduces the system complexity and improves the development and access efficiency. To define what is big data, the big part of big data is indicative of its large volume. In addition to volume, the big data description also includes velocity and variety. Velocity indicates the speed or rate of data collection and making it accessible for further analysis, while the variety remarks on the different types of organized and unorganized data that any firm or system can collect, such as transactional level data, video, audio, text, or log files. These three V's have become the standard definition of big data, although the other people have added several other V's to this definition. The most accepted fourth V remains the veracity. The term big data has become extremely popular across the globe in the recent years. Almost every sector of the research, whether it relates to industries or academics, is generating or analyzing big data for various purposes. The most challenging task regarding this huge heap of data that can be organized and unorganized is its management. Given the fact the big data is unmanageable using the traditional software, we need technical advanced application and software that can utilize fast and cost efficient high-end computational power for such tasks. Artificial intelligence in this aspect. The implementation of artificial intelligence algorithms and novel fusion algorithms would be necessary to make sense from this large amount of data. Indeed, it would be a great feat to achieve automated decision making by the implementation of machine learning methods like neural networks and other AI techniques. However, in absence of appropriate software and hardware support, big data can be quite hazy. We need to develop better techniques to handle this endless sea of data and smart web applications for efficient analysis to gain workable insights. With proper storage and analytical tools in hand, the information and insights derived from big data can make critical social infrastructure components and services more aware, interactive, and efficient. In addition, visualization of big data in a user-friendly manner will be critical factor for societal development. Now, healthcare as a big data repository. The health professionals belong to various health sectors like dentistry, medicine, midwifery, nursing, psychology, physiotherapy, and many others. Healthcare is required at several levels depending on the urgency of the situations. Professionals serve it as the first point of consultation. Acute care required skilled professionals, advanced medical investigation and treatment, and highly uncommon diagnostic or surgical procedures. At all these levels, the health professionals are responsible for different kinds of information such as patient's medical history, medical and clinical data, and laboratory and other private or personal medical data. To talk about the wireless communications and mobile computing in this topic, simple analysis includes personal retail consumptions records reflecting lifestyle habits that can be used to access the personal health risks and develop personalized health plans. Based on the physiological data collected by wearable devices, the user's health can be easily monitored and tracked. Personal emotion data can be collected through information posted on social networks and can be used for mental health measures and emotion calculations. Particularly for rehabilitation of patients, doctors can adjust the treatment plan based on the patient's emotion. The emotional perception of medical services. Adapter is a data node that provides access to system middleware. Now, simply the physical data link or the original data preprocessor and the encryptor. In addition to cleaning up the data, removing redundancy and compression, the preprocessing module also supports data conversion. Depending on the type of data collected, the adapter uses a system-defined data standard for format conversion. The encryption module encrypts the preprocessed data to ensure security via hierarchical privacy protection. Unauthorized devices cannot decrypt the packets even if they have access to the system. Now, to talk the simple analysis, the distributed network storage system adopt a scalable system architecture that utilizes multiple storage servers to share the storage load and uses the location server to locate and store information. This not only improves system reliability, availability, and access efficiency, but it is also easily expandable. The distributed storage architecture consists of three parts: the client, the metadata server, and the data server. The client is responsible for sending read and write requests, cache file metadata, and file data. The metadata server is responsible for managing the metadata and processing the client request and is the core component of the entire system. The data server is responsible for storing the file data to ensure the availability and integrity of the data. The benefits of this architecture are that both performance and capacity can be expanded simultaneously, and the system is highly scalable. To talk about the distributed storage is facing more complicated data needs, which can be divided into three categories. Unstructured data. This unstructured data include all formats of office documents, text, images, audio, and video information. Second, structured data. This structured data are stored in data relational libraries. One can use two-dimensional relational table structure representations. The structured data scheme and the content is separate, and the data models needs to be predefined. The third is the semi-structured data. Between unstructured data and structured data, like the HTML documents belong to the semi-structured data category. Such data are generally self-describing, and the biggest difference from structured data is that the schema structure and the content of the semi-structured data are mixed, with no obvious distinction and no schema structure that predefines the data. To talk the idea of big data in healthcare, the various public and private sector industries generate, store, analyze big data with an aim to improve their services they provide. In the healthcare industries, various sources for big data include hospital records, medical records of the patients, results of the medical examinations, and devices that are a part of Internet of Things. Biomedical research also generates a significant portion of big data relevant to public healthcare. This data requires proper management and analysis in order to derive meaningful information. Otherwise, seeking solution by analyzing big data quickly becomes comparable to finding a needle in the haystack. There are various challenges associated with each step of handling big data, which can only be surpassed by using high-end computing solutions for big data analysis. That is why, to provide relevant solutions for improving public health, healthcare providers are required to be fully equipped with appropriate infrastructures to systematically generate and analyze big data. And efficient management, analysis, and interpretation of big data can change the game by opening new avenues for modern healthcare. That is exactly why various industries, including the healthcare industries, are taking vigorous steps to convert this potential into better services and financial advantages. With a strong integration of biomedical and healthcare data, modern healthcare organizations can possibly revolutionize the medical therapies and personalized medicine. To conclude this, medical data released and shared through the cloud are very popular in practice, and information and knowledge bases can be enriched and shared through the cloud. The revolution presented by the cloud and big data can have a huge impact on the healthcare industry, and a new healthcare system is evolving. This is why we need to design a more appropriate healthcare system to meet the challenges presented by this revolution. The diversity of the data sources requires a uniform standard of heterogeneous data management. On the one hand, due to the diversification of medical equipment, the data formats and amount of data generated by various devices may be quite different, which requires that the system support data access by various medical devices to ensure high scalability and satisfy actual medical needs. This paper has given the details as literature study on computational healthcare systems for sustainability. Thank you one and all for giving me an opportunity to present my paper in front of all the eminent people here. Thank you.